All right, everyone. Hopefully, you all had a very good weekend. So just an update. So this is our last lesson for Unit 4. Your quiz for Unit 4 will be on, I'll make it Thursday this week. So you have 3 days to study. It'll be the stuff we did from basically all of Unit 4. And then your assignment will be on Monday, okay, which involves Unit 3 and 4. For the next unit for trig, there will be a quiz midway, so it's not a quiz on the whole unit, but a quiz on the first few lessons. And yeah, so today we're gonna do lesson 4.5. Tomorrow we are going to start with trig, and on Friday I'm probably gonna do a bit of review with you guys for the assignment on Monday. Okay. So we're going to be doing trig tomorrow, Wednesday, and Thursday, and half of Friday. Okay. So I don't think we'll get through the whole trig unit this week, but we might get through most of it. But right now we're just going to focus on 4.5. Okay. Which is solving rational inequalities. Okay. Remember, with rational equations, you can cross multiply. But when it comes to rational inequalities, you cannot cross multiply, okay? So let's just start with the first example. So solving, and like I said, guys, when we're doing this online stuff, I'm free from 12 p.m. up until class starts. I had, I think, 3 people today ask me questions about the homework. So if you ever want to ask me questions about homework and we're online on those days, just feel free to ask me and I'll be more than happy to help you guys out. Okay. So we're going to be doing solving rational inequalities. So solving rational inequalities is very similar to solving polynomial inequalities, but because rational expressions have denominators and therefore may have places where they are not defined, you have to be a little bit more careful in finding your solutions. Okay. So rational inequalities can be solved either by graphing or by an algebraic approach. So we're going to take a look at this example of the inequality 2 over x minus 5 is greater than 10. So we're going to take our expression. So our expression is 2 over x minus 5 is less than 10. Okay. So what we want to do first is we want to arrange the equation so that the right side equals 0 and then simplify the left side. Okay. So we're going to move the 10 over. So we get 2 over x minus 5 minus 10 is less than 0. And then we're going to take the common denominator in this case, which is x minus 5. So we get 2 minus 10 times x minus 5 over x minus 5 is less than 0. And then what we're going to do is we're going to FOIL the 10 into the bracket. So you get 2 minus 10x plus 50 over x minus 5 is less than 10. And when we simplify that even further, we get negative 10x plus 52 over x minus 5 is less than 0. But before we continue, what would our restriction be for this inequality? So x cannot equal 5, okay, because we never want our denominator to be 0. And when x is 5, that just means it is a vertical asymptote, okay? So that would be our first step, is rearranging the equation from simplifying the equation from the original. So our simplified equation is 10x plus 52 over x minus 5 less than 0. okay? So we can identify two things from the simplified expression. So we can identify our vertical asymptote, which is usually given by our denominator. So what is the vertical asymptote in this case over here for this equation? So we have x is equal to 5. So that's going to be one of our asymptotes. And based off the degree of our numerator and denominator, we also have a horizontal asymptote. So since we know the degree of the numerator and the denominator is the same, what would our horizontal asymptote be if we took the ratio from the numerator and the denominator? Y is equal to negative 10. So we would have a horizontal asymptote at negative 10. So you have y is equal to negative 10, and x is equal to positive 5 as our vertical asymptote, okay? And then we can also identify our x-intercept. So if we set that that rational or reciprocal function equal to 0, what is our x-intercept? What would our x-intercept be if we set all of this equal to 0? So if we cross multiply, we can cross multiply because we're finding the x-intercept, okay? That's the only reason we can cross multiply in this case. So we get negative 10x plus 52 is equal to 0 times x minus 5. And we know anything times 0 gives us 0. So Joseph says 26 over 5. It is 26 over 5. So x is equal to 26 over 5, or negative 5.2. No, it should be positive 5.2, sorry. Positive 5.2. So our x-intercept is going to be somewhere in this general vicinity. Okay, so now we have our x-intercept, we have our vertical and horizontal asymptotes. What else do we need to determine how to sketch this graph? Plus 1, minus 1. That's not a bad guess, but also what else? Not the end behaviors, but the behaviors approaching what? Behaviors approaching the vertical asymptotes, okay? But yes, we can also find the y-intercept. So let's find the y-intercept. So we set x is equal to 0. And what would our y-intercept be? Negative 10.4. That is going to be over here. Okay, so now to graph the rest of it, we need to figure out the behavior approaching the vertical asymptote from the left, and the vertical asymptote from the right. Okay, so when we do this, generally I would like for you guys to pick a number that is 0.01 to the right and 0.01 to the left. Okay, so we're going to take a look at the behaviors approaching vertical asymptote. Okay, so you want to take a look at 5 to the right. So what is an x value that is to the right of 5 that is 0.01 greater than 5? So we're going to look at f at 5.01. The reason why I picked such a small interval is because if I go, let's just say if I pick f at 6, it's still to the right of 5, but it's going to give me a number that is less than 0. Okay, so it's going to give me a negative y value, and we don't want that because even though it's negative, we can't assume it approaches negative infinity. Okay. So usually the behaviors are on the vertical asymptotes. The closer they are to the vertical asymptote, it'll determine the direction that graph is going, approaching it from the right or from the left. So when we sub in f at 5.01, what sign does our numerator give us, positive or negative? So you get positive on the top and positive on the bottom, which means it approaches positive infinity. So now we're going to take 5 to the left. So we're going to take f at 4.99. And if we sub in 4.99, what sign do we get on our numerator? We get positive. And how about our denominator? We get negative. So that means this approaches negative infinity. So as x approaches 5 from the right, y approaches positive infinity. And as x approaches 5 from the left, y approaches negative infinity. So now, given this information, we can now determine how to sketch this graph out. So as x approaches 5 from the right, y is going to approach positive infinity. And as x approaches 5 from the left, the y's are going to approach negative infinity. So like I said, you can sketch these graphs without really using the bare minimum number of points, and by just focusing on the behavior approaching the vertical asymptotes. So is everyone good with this example so far? Okay, perfect. So hopefully this gives you guys more practice on graphing those rational functions without, I guess, with just using the X-intercept, Y-intercept, and the behaviors approaching the vertical and horizontal asymptotes. So now we want to state a solution set for the inequality. So for the inequality, it wanted the values where the function was less than 0. So we wanted negative 10x plus 52 over x minus 5 to be less than 0. Okay? And based off the graph we drew, at what points or at what intervals is that inequality less than 0? In case we have x is less than 5. So our first solution, or our first interval is from negative infinity to positive 5 in union with where else is this graph less than 0? Well, remember, even though it is 0.01 to the right of 5, 5.01 is still greater than 5, but it's approaching negative infinity. So take a look at the X-intercept that we found. So greater than 5.2. So in union with 5.2, all the way to positive infinity. Okay? So as we can see, from negative infinity all the way to the asymptote, this graph is less than 0. Okay? However, we can't say the same thing about x being greater than 5. From 5 to around 5.2, this graph is bigger than 0, but from 5.2 and onwards, it is going to be less than 0. Okay? So does everybody understand the solution or the interval notation for the inequality? Okay. So we're going to solve the same question above algebraically. So we solved it graphically for the first part of the lesson. Now we're going to solve it algebraically. Okay? So what did we use last week to determine the behaviors of the graph, whether it be positive or negative? What kind of chart did we create to solve those problems algebraically? So what charts did we use to figure out the behaviors of the graph when we factored it all out? So remember, we used the sign chart, okay? So that is what we're going to use to solve this problem algebraically. But first, we need to find the zeros and state the restricted values. So we said our restrictions was that x could not equal to 5. And we said our roots where x is equal to 5.2. Okay? So now this handout does the sign chart for this question a bit differently than I do. I personally like the factors to be on the left-hand side and the zeros and intervals on the top of the table. Okay, so I'm not going to use the sign chart that they gave us. Not saying that it's bad, but I understand. Hopefully, you guys understand it better this way. And plus, we've been using the way I showed you guys already for a couple of lessons. So I don't want to show you guys something new and then all of you get confused. Okay, so we have our roots. So we got x minus 5. We have 52 minus 10x. And then we have our product. Okay. So in order from least to greatest, we have negative infinity. We then have positive 5. We then have 5.2. And then we have positive infinity. Okay? So using the sign chart, let's use the first interval. So we want to pick a value between negative infinity and positive 5. To sub in for our expression. So what number do you guys want to sub that's between negative infinity and positive 5? Okay, let's sub in 1. So if we sub in 1 for our factors, we get 1 minus 5, which is negative, and we get 52 minus 10, which is positive, which means our product is going to be negative, okay? And because our inequality is less than 0, a negative number means that it's less than 0. And now someone give me a number between 5 and 5.2. So let's take 5.1. If we take 5.1, we get positive here, and our product is going to be positive, and we can't use that because we're looking for where the y values are less than 0. Okay, and last but not least, we're going to take a number between 5.2 and positive infinity. So let's take positive 6. So we get a positive value for our denominator, but we get a negative value for our numerator. And a positive times a negative gives us a negative value, okay? So as you can see, if we were to write this in interval notation again, what would our interval notation look like? So our interval notation would look exactly the same. So we have negative infinity to positive 5 in union with 5.2 to positive infinity. Okay? And it's the exact same solution set we obtained when we analyzed this graph graphically. Okay? We got the same answers. One of you might find doing it graphically easier or doing it algebraically easier. So which way do you guys find it easier to solve for these solutions for these inequalities, graphically or algebraically? Would you guys rather graph it out or use the sign chart to just figure it out quickly? And I don't blame you guys. As cool as drawing graphs is, using the sign chart is going to get you to the solution 10 times quicker. Just give me 2 minutes. I'm just going to take attendance. So just bear with me for a bit. Okay, so that's done with. So now we're going to take one more example and we're going to solve it algebraically so that we don't waste our time doing the graph. So and step 4, so the last step when doing it algebraically is determine where the overall expression satisfies the original inequality. So our solution should be stated by a solution set, interval notation, and graphed on a number line. Okay? So our set notation, what it would look like is XER such that X is less than 5 or X is greater than 5.2. And for our interval, we already discovered it like 5 times. So we have negative infinity to 5 in union with 5.2 to infinity. And then we're going to draw our number line. So we have 5.2 over here, and we have 5 over here. Are we going to have a closed or open circle? So we're going to have an open circle on both 5.2 and 5. Because we said X is less than 5, everything is going to go to the left of 5. And because we said X is greater than 5.2, everything is going to go to the right of 5.2. Okay? So that's how we would represent our solution in set notation, interval notation, and represent it on a number line. Does anybody have any questions so far about this lesson? Nope. Okay, we're good. So like I said before, if you ever have a question, just unmute your mic and just, ask it to the class. Because chances are other people in the class are going to have the exact same question you have. So now we're going to move on to the last 2 examples. So we want to solve the following algebraically and state our solution as a solution set and graph it on a number line. Okay? So again, we're going to be doing the same thing. So we need to bring the expression on the left side over to the right side. So we get 5 over x plus 4 minus 2 times x plus 1 less than or equal to 0. Before we simplify, let's just state our restrictions. What would our restrictions be for this expression over here? X cannot equal -4 or -1. Okay. So now we're going to pick the common denominator, which is x plus 4 times x plus 1. So we're left with 5 times x plus 1 minus 2 times x plus 4 over x plus 4 times x plus 1 is less than or equal to 0. And then all we're going to do is simplify. So we're going to FOIL our 5 into the bracket and the -2 into the bracket as well. So we get 5x plus 5 minus 2x minus 8 all over x plus 4 times x plus 1 less than or equal to 0. And then we're going to collect our like terms. And we're left with 3x minus 3 over x plus 4 times x plus 1 is less than or equal to 0. Now we need to figure out our roots, okay? So remember the roots of the rational inequality has to do with the numerator. So if we set the numerator equal to 0, what is our x-intercept for this expression? 1, okay? So we got 3x minus 3 is equal to 0. Move the 3 over, divide by 3, and we get x is equal to 1, okay? And now what's the last step to determine the behaviors of this rational function? What kind of chart are we going to create? So what's left to do is we're going to create the sign chart. So with our sign chart, we have our three expressions. So we have 3x minus 3. We have x plus 4, x plus 1, and we have our product. So you have negative infinity. Remember with the sign chart, it's from least to greatest. We have negative 4, negative 1, positive 1, and infinity. So now, like we did in the previous example, we want to pick a number between negative infinity and negative 4. So what would a number between negative 5. So if we sub in negative 5 into our factors, we get negative, 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 and 3 negatives multiplied by each other give us a negative, and this is what we want, okay? Because the negative entices less than or equal to 0. Now our next interval we're going to look at is between negative 4 and negative 1. So James, we're going to use your answer, okay? We're just going to use negative 2. When we sub in negative 2 for our factors, we get a negative, a positive, and a negative, which gives us back a positive, and that is not what we're looking for. And what's the only number between negative 1 and 1? So for the next one, we're going to sub in 0. So we get negative, positive, positive, but that just gives us back a negative. And somebody give me a number bigger than 1. So we're going to use 2. So we get positive here when you sub it for x, 3x plus minus 3. We get a positive when we sub it for x plus 4. And we get another positive when you sub it for x plus 1. And that gives us positive. So we want to state it and set notation. So again, with set notation, we're going to start with XER. Such that, what are our conditions for this solution set? Yeah, x is less than or equal to negative 4. Well, is it less than or equal or just less than? Can we have our denominator be 0? Yep, so it's just going to be less than. So it's going to be less than negative 4. Or what is our second condition? Yeah, between 1 and negative 1. So x is greater than negative 1. We can't have the greater than or equal to, because then we can't have our denominator be 0. But for the next condition, we can say less than or equal to 1, because that 1 just affects the numerator, and our numerator can be 0. Okay? And now we're going to write it in interval notation. So we get negative infinity to negative 4 in union with negative 1 and 1. So is the positive 1 going to have a square or round bracket? It is going to have a square bracket because, like I said before, our numerator is allowed to be 0. And last but not least, we're going to represent it on a number line. So we have negative 1, positive 1, negative 4. So which numbers on the number line are going to have open circles? So negative 4 and negative 1 are going to have open circles, and positive 1 is going to have a closed circle. So we have our interval, anything that is less than negative 4 is going to go to the left of negative 4, and our interval between negative 1 and positive 1. So does everyone agree with the solution? Okay, perfect. And then last but not least, we have our last example. And our last example is we have x plus 3 is equal to x plus 1, which is greater than or equal to x minus 2 over x minus 3. Okay, so all we're going to do first is we're going to bring the expression from the right side over to the left. And before we go any further, what are our restrictions for this expression? So x cannot equal 3 and positive 1. And negative 1. Okay. And now all we have to do next is find our common denominator, which is just x plus 1 and x minus 3 combined. So we get x plus 3 times x minus 3 minus x minus 2 times x plus 1 all over x plus 1, x minus 3, and all greater than or equal to 0. So now all that's left to do is to FOIL the expressions or multiply the brackets with each other and then just expand and simplify, okay? So remember, you're only expanding and simplifying for the numerator, not the denominator, because it's already simplified, okay? So what we're left with is x squared minus 9 minus x squared plus x plus 2 over x plus 1 times x minus 3, all greater than or equal to 0. So now we're going to collect the like terms and simplify. So the x squareds cancel each other out, and we're left with x minus 7 over x plus 1 times x minus 3 greater than or equal to 0. So based off the numerator, what is my root for this expression? So my root is x is equal to 7. Okay, now we have all the necessary information to create a sign chart so that we can solve for where this rational inequality is greater than or equal to 0. So we have our expressions. We have x minus 7, x plus 1, and x minus 3. And we have the product at the end. We have negative infinity. We have negative 1, positive 3, 7, and infinity. Okay, so someone give me a number that's less than negative 1. So negative 2. So I'm going to get a negative back on every single one of them, which means my product is going to be negative. But this time we want numbers greater than or equal to 0, not negative numbers, less than 0, okay? And what's a number between negative 1 and positive 3? So again, we'll take 2. We'll get negative, positive, negative, but at the end it'll give us a positive number back, which is what we are looking for. What's the number between 3 and 7? So we'll go with 5, negative, positive, positive, but at the end it just gives us back a negative. And last but not least, what is a number bigger than 7? So we'll take 8. And all this is going to do is give us back positive numbers, which is what we want. Okay, so when we write it in set notation, we get XER such that x is less than 3 and greater than negative 1, or x is greater than or equal to 7. Okay? Remember again, the reason we don't have the less than and equal to sign beside the 3 and the negative 1 is because we can't have our denominators be 0. And for interval notation, it would be negative 1, negative 1 to 3, in union with square bracket 7 to positive infinity. And for our number line, let's see where I can draw this. Let's erase this. So we have negative 1, 3, and 7. So again, which numbers are going to have an open circle? So 1 and 3 are going to have an open circle, and then positive 7 is going to have a closed circle. So everything bigger than 7 is going to go point an arrow to the right. And then we have everything between -1 and +3. So do you guys find the sign chart super easy now? Okay, so that's pretty much it for Unit 4. Okay, like I said, we will have our Unit 4 quiz on Thursday, and your assignment will be Monday. Okay, so let me just type it out. Tomorrow we will start trigonometry. Okay. Thursday you'll have your quiz, so we may or may not get through a lesson depending on how quick you guys finish. And on Friday I'll do a review for you guys for chapter 4, especially with the reciprocal graphing and the behaviors approaching the X and Y intercepts, not the X, the vertical asymptote, sorry. So we'll do a little bit of review on that. And then Monday you will have your assignment for Unit 3 and 4. Okay. So other than that, you guys are free to go. You guys can work on the homework. Start on the chapter 4 review. Okay. For those who have the package, you guys have the extra practice